Math 1314, Tyler Junior College, Section 2.6, Combinations of Functions, Composite Functions, Composition of Functions, Part 2. In the previous video, we defined the composition of two functions, f of g of x equals f of g of x, and we defined the domain of a composition of functions. Although the definition was a little janky, if you will, the application of it was pretty straightforward. You take the intersection of the inner functions domain and the final functions domain. So this example is pretty much like the one before, except now we have domain issues. In the previous video, our two functions were polynomials, so no denominators, no square roots, no problems in the domain. The domains were all real numbers all over the place. But these two functions, being rational functions, have denominators and therefore have domain issues. Before we get started, let's just quickly point out what we can't put into each function. For the f function, because the denominator is x minus 1, you cannot put in x equals 1, so we'll say x is not equal to 1. And for the g function, because the denominator is x, we cannot put in x equals 0. When the time is right, we'll look at the domains of the compositions. Let's start with f of g of x. Just like before, I'm going to do the work over here. For f of g of x, by definition, this is f of g of x. And it just dawned on me that in the previous video, I didn't point out how to fast forward past the two steps. Maybe I'll remember this time. To start setting up the function, go to the inside and replace it with what it equals. In this case, g of x is equal to 3 over x. So let's replace that with 3 over x. We'll write it in red for contrast. If you're colorblind, my apologies, but this is red. Now we have to perform f of 3 over x. And remember, to insert an expression into a function, copy the function, so we'll copy f of x, but where there are x's, we'll put parentheses. So instead of 5 over x minus 1, we'll put 5 parentheses minus 1, and then fill in the parentheses with the inner function. To accelerate the process and start here, you simply write the outer function with parentheses instead of x's, so the function in black. And in the parentheses, you write the inner function, which in this example is in red. Now, are the parentheses necessary? In this case, the answer is no. But we need to clean this up. It is considered unsimplified and therefore unfinished to leave fractions inside of fractions. I'm going to erase these parentheses. There's nothing in front of them requiring them to be there. That's mainly why we do the parentheses, in case we have to set up a distributive property or a FOIL problem. Do you remember the trick for getting rid of a little fraction and a big fraction? I illustrated it in a previous video. To get rid of a little fraction that's in a big fraction, you simply have to multiply both sides of the fraction by the denominator of the little fraction. So we're going to multiply both sides of the big fraction by x. On the top, all this does is give us a 5x. But on the bottom, the x gets distributed. When it distributes to the fraction, it cancels its denominator and leaves a 3, minus, and then when it distributes to the 1, 1 times x is x. At that point, we're done simplifying the function. Our composition is 5x over 3 minus x. Well, what about the domain? Well, define the domain. Go to the inner function and go to the final function. The inner function was 3 over x. What is the one number we cannot put there? 0. So I'm going to make a note that x cannot equal to 0 because of the first function the x goes into. But look at the final function that the x has to get past. It has a denominator. And according to this function's denominator, what can x not be equal to? Or equivalently, what will make 3 minus x equal to 0? 3. If you'll notice, 3 was not an original exclusion. 0 was, and 1 was an original exclusion, but now it's not excluded. Let's go ahead and write the domain and we'll talk about what's going on with this part of the definition. The domain of the composition has to exclude 0 and it has to exclude 3. We don't need number lines. Start at negative infinity, stop at the first number you need to exclude, 0. Close the interval with the parentheses, union, open it up and keep going until you run into any other numbers to exclude, which in this case is 3. Close that off, union, open it again, continue after 3. There are no more numbers that need to be excluded. This goes to infinity. So why is 3 excluded? It wasn't bad in the first function, it wasn't bad in the second function, but watch this. This whole mess over here is saying, don't keep any number that when it comes out of the first function can't go into the second. Here's why we can't keep the 3. The first place the 3 is going is into the g function. I can put 3 here. When I put 3 here, what do I get? 3 divided by 3 is 1. But that 1 coming out of the first function now goes into the second. Ah, but it can't. So 3 is bad, not because of what happens when it goes into the first function. It's okay. But when it comes out of the first function, I can't stick that into the second one. And that's all this is saying. You keep all the numbers in the first domain whose output from the first function belongs to the second domain, because whatever comes out of the first function has to go into the second one. Let's try the other one, g of f of x. This one will be a little bit quicker. Doesn't look like it, but trust me, it will. Actually, it's about the same speed. Let's see if we can fast forward this. If you need to write both steps, you do, but I should practice what I preach. To set up a composition in one move, you start by writing the outer function. The outer function is g of x, that's 3 over x. But when you write it, replace the x with parentheses. This is what g does. Give me something, I'll stick it under a 3. What it's doing it to is this function. So this function goes inside of there. F of x is 5x minus 1. So you can accelerate the setup by writing the outer function with parentheses and filling in the parentheses with the inner function, and then going to town. Now, actually, I just thought of a brilliant reason not to do this. G of f of x means g of f of x. Replace the inner function. F of x is 5 over x minus 1. Insert that into the outer function. The outer function g of x says, give me something and I will put it under a 3. And the thing it's going to put under the 3 is the 5 over x minus 1. I knew there was a reason I didn't want to fast forward. The issue has to do with the domain, which we'll get to in a moment. Let's clean this fraction up. We have a little fraction inside of a big fraction. And you can always fix that by multiplying both sides of the big fraction by the denominator of the little fraction. So if we multiply both sides by x minus 1, the x minus 1's cancel in the denominator, but not in the numerator. The only thing left in the denominator is the 5. In the numerator, we can distribute and get 3x minus 3. So, our composite function is 3x minus 3 over 5. But what's the domain? Again, to find the domain of a composite function, you look in 2 places. You look in the first function, the inner function, can't put in 1. And you look in the final function. Oh, wait a minute. There are no restrictions here. The denominator is 5. No value of x will magically make this denominator 5. So the domain here is negative infinity to infinity. So my domain is the intersection of the 2. It's everything except 1. So negative infinity comma 1, union 1 to infinity. Why didn't we have another domain issue? Well, think about it. In order for g to be undefined, it needs to receive a 0. What can we put into this function to get a 0 out? The answer is nothing. This function will never equal 0, because in order to equal 0, the top would have to be 0, and it's always 5. So no number that comes into the f function will come out as 0, so there were no other domain exclusions. I'll admit the domain issue is a little bit sneaky on composite functions. You just have to ask yourself, what journey is the x undergoing? It must first get past the inner function, so domain here, and it has to get past the last one as well, domain there. As a challenge, I invite you to find one more composition. G of x. You can compose a function with itself. The result might surprise you.